So today's talk is really about identifiers, unique identifiers in a data store. We're talking about Elasticsearch. And so in Elasticsearch case, it's always called the underbar ID field. But the real thing we're going to talk about is what can go into that field, what represents a key, and what is the meaning of a key in a data store. And I'm talking mainly about Elasticsearch, but you know what? It applies for SQL database, for basically any document or record store. A key represents a single record, and we're going to talk a little bit about the makeup of that key and how it can be done. And a retrieval of a key always returns. So that would be like a get. If we call a get a point API, we're going to do a point retrieval based on a key. You always get the same record. That doesn't mean you get the same data back, right? So you might get something completely different. And actually, if somebody messes up and they replace that data for that key with some other person. So the point, though, is that the key represents a record in the data store and may represent a real entity. But there are cases, the way we do keys, we could end up with the same entity inserted in a data multiple times on purpose, and those would all end up with different keys. So changing the data bound to a key and retaining the key always represents the same row. So we're going to talk a little bit about how the key can actually be generated. Now, the point, though, was if it's the same key value, it is the same record no matter what's in the record. So we may want to be able to do meaningful keys, and so that we don't end up with different entities' data. Anyway, the net is the same key always points to the same record no matter what's in it. The key represents the row. And if you're doing a search, you can get different data back. Show me all the people whose last name begin with FREE, because my name's Freeman, in a certain zip code, and that might return different people back at different time. But if we knew my customer identifier, whenever we did a point retrieval based on that customer identifier, we'd always get the same person, even if I changed my name and my address, right? I went into the witness protection program, and they changed everything about me, but I just shoved all that data back into that, under that key. Whenever you retrieve the key, it would still be me, even though nothing in there. So it kind of depends on how you create a key, and there's really three main kinds of keys. Well, two of them are similar. So one of them is a synthetic key, and that is something that is unrelated to the data at all. It purely exists to support the data store. So if I had a bunch of events, right, or log messages really don't have any meaningful business key. But so I might just create a unique identifier for each row. And then if I wanted to get back to that, if I ran a query and I got a bunch of log messages and I'm like, oh man, you really need to look at log message 42 here. It's got this synthetic key that was generated. It doesn't mean anything with the data. It just means that record has a unique key that whenever I query by that, I get the same like log record in that case back. The next one is native key. Native key and calculated key are kind of the same idea, but native key to me is a field or attribute that is unique. So it might be like a social security number. I was working with some DOT trucking data, and the DOT truck, DOT identifier number that each trucking company gets is unique, and so therefore the key there could be that. And so even if that trucking company changed its name, as long as it retained the same DOT identifier, we'd always get the same record back representing the same company. So the native key, in this case, I'm just going to say is a field that, and it could be a combination of fields, but we're going to talk about a calculated key in a minute. And the idea is it's guaranteed unique. And then you have a calculated key, which is combination. So driver's license is not number, for instance, in the United States is not a unique key because there's different states could issue the same driver's license number. So to be a unique identifier, not a synthetic key, but a unique identifier, you could do a calculated key around driver's licenses, and that would be the state and the driver's license identifier. So what it means, though, is the contributing fields can't change, because if they change, then the calculated key would change, and therefore it represents a different record. So I couldn't use a driver's license, active driver's license, to be a unique identifier in my database for a person, because that person could move and get a new driver's license in a different state. The calculated key would change, and we'd think they were a different person. So that's an example of that, right? So unique key, depending on the usage of your data store, can be synthetic, it could be a single value, it could be a calculated value. And the calculated value may go through some kind of hash or other. The question is, how does that calculation work to make sure that records can't collide and end up with the same calculated key. So synthetic key, this is system generated. I'm just going to show you this. You're going to use Elasticsearch as a value. So if I were to do an input and I were to say the source is the source record, right? You'll see that no ID has been provided. The loader loads the data, calls Elasticsearch and does a load. What will happen is Elasticsearch will actually use the unique key generator, and it will generate basically a GUID. And it'll generate a GUID for the ID field, and it'll insert that record with the GUID. So the same data, you'll notice here, right? No ID is passed in. So if I were to reinsert the same record multiple times, I'll actually end up with multiple records in Elasticsearch with different keys because the key isn't generated from the data. And yeah, and so that's cool. Now they might generate it. No, they don't. So there you go. So the next one is you could do synthetic key externally generated. This is actually the same thing. Exactly the same, except in this case we didn't let Elasticsearch, we just provided it. So my Python or other program here uses a GUID generator, and that way we never let Elasticsearch actually generate any of the identifiers. We always provide identifiers ourselves, and we determine whether it's going to be something synthetic or calculated or just a natural field. So the loading program generates the ID, and really, I don't know why I put the needs to run the query, but that's basically it. That's the second option for synthetic. So natural key, what I'm going to recommend here is like if I ended up with a DOT number, for instance, or a doctor identifier in like the Medicare system, that you may want that field to be in the ID field and in the data part. And it turns out that's because of the way Elasticsearch works. A lot of times people will take a field and just make it the ID field. If it's not too long, I just recommend putting it in both places. The ID field and how you use it in the data part of this are actually different. So in this case, we took an ID field. On the left side here, we just took an ID field, the record ID field, and that record ID field would also go in the source. So we just replicate, the loader would basically, through the call, replicates the ID value into the ID field passed in as a parameter, and then the Elasticsearch does a record inserter. So Elasticsearch has no idea that the same value ends up in two different places. On the right-hand side, you can actually do this with a pipeline. The left-hand side was just calling it direct, but you can also do this with a pipeline. It's really no different between the two, except one has a pipeline. I think pipelines are cool. So then you have the calculated one. This one actually, of course, we're going to end up with two different ways we can do this. In this case, if you want to do a calculated key in Elasticsearch, which is a combination of fields, that's actually kind of a fingerprint. So in this case, we can use the fingerprint processor. You're going to have to use a pipeline. So remember, if you look at this, we're providing data to Elasticsearch without an ID value. And somehow we want to take a combination of fields that are in the record that's being passed in and convert that into the key. And so what we do is we configure a pipeline with a fingerprint processor. A fingerprint processor, we tell it, this is actually, I can't remember which one this one's from. I think, this is actually from DOT crash data here, or inspections. I can't remember which. And so we're going to generate an ID field inside Elasticsearch, but in the pipeline using the fingerprint processor. So the loader, in this case, we have to use a pipeline because we're going to use a pipeline feature to generate that key. So the other way is we could have generated this externally. I like the pipeline thing because then if you have multiple programs inserting data into the same table, it all works the same. The other way to do this is similar to what we did with native on the second version. We don't have to use a pipeline. So if we're going to do fingerprint or any of those other kinds of generators inside Elasticsearch, we're going to use a pipeline. If we don't want to use a pipeline, we could write a Python or Go or Java or whatever program to calculate that value from multiple fields in the record, and we would pass it in as if it came, just like we knew what it was. And so that's really up to you. Do you want any of these calculations to occur inside Elasticsearch, or do you want them to occur external to Elasticsearch, right? The main goal of all this always, though, the reason I like the fingerprint one is you never have like drift in the algorithm. But the same point is the same source fields always generate the same key, right? So like if you were to keep inserting the same data and over again, you still only end up with one copy of the record with any of the calculated or the native key. So picking an ID pattern, the real question is, do you have a single native element that uniquely defines a document? If you do, just insert it into the ID field, and I recommend into a data field. Do you have multiple native elements that uniquely identify a document? Then use a fingerprint. and a pipeline, or you can have your external program create some kind of hash to combine those together. The hard part is you want to make sure it is always unique no matter what the data is in the fields. So that can create a couple things. You tend to end up using the field name and the value, because otherwise, well, anyway, you get the idea, right? Like I could have two people, Freeman J, and I could have Free Man J, and those might end up with the same hash if I don't do it correctly. And if none of those, just use a synthetic, right? That should, instead of say generate, it should say use synthetic if none of the above. And so that's it. I'm over time. I think that's the end of this. Yep, some of the examples where I did this are all in Entitopia. Actually, pretty much all these out. None of the program generated, but basically combo fields using a pipeline, raw data, and synthetic are all used in this as an example. So I hope that's useful for you, and I hope I talked loud enough. Have a great day.